Lecture 39. We continue to work on the news portal. The news portal is based on the streaming framework. Now we need to start from we finished one of the publisher. The publisher, we focus on publisher. Publisher is based on the CS client, right? CS client, this is our project. Publisher, this is publisher, right? Publisher. But we have four, at this time we have five publisher, but four of them publish string, just message. All the data is published in the format of string. We call it message, but one of them is a video. So video is a little bit difficult. So now we need to work on the video. This one. So to implement such a publisher, we need to load the data from the disk. The video is usually the size of the video is large. We have to load the data piece by piece. That's why we need to. That's different from the message. Message is lightweight data, so it's easy for us to handle that. So we need to design another publisher, but we can follow the code here. Follow this code. Okay, and then this data is loaded from the disk. Oh, this is a string. This is a string. This is a file, text file. All the files are put on the list. However, in this case, we need to load the stream in video. So it's a little bit difficult. So we need to use this one. Right? We need to use this API. Okay. So let me try. For example, we also need to access this video, right? The format is MP4. So here we need to define okay, let us define news portal. News portal. News portal. We need to define some constants to this. Some constants, the file size, the piece size. Yeah, we need to decide the path. So I want to create a config file, so all the constants are put into it. Okay, then can make a change. Okay, sorry. It's a publisher, so this one, okay, that's fine. And what else we can do? So we use the same file. Okay, this is a video. Then we can load data. status. Now it's not so difficult because this code has nothing to do with the distributed system programming. Okay. Okay, so what is your category? So the category should be video, right? For this case. So the category options. We have some options here. So the category for this case radio, and then we need to load the data from the disk. You can copy this code here. Okay. Okay. Copy this data. Use config. Okay. So here we do not save the data. We just need to transmit the data to the remote, to the root. After one piece is transmit, we need to sleep for some time. Okay. Now we can, the data is loaded, path is here, so we can publish the data. Let me check this one. Publish, okay. We can invoke publisher and publish stream. For this case, there should be video piece notification, right? Let me check the constructor of video piece notification. Okay, that's a post. There is a post. Need to be defined. Post message. Okay, well, there is a message. Okay, we just design that this way. Publisher name, category, and the message, maybe we can use this one. Define a message piece add. Okay. Publish, no. News config piece head, then we can use the index, right? Index. Let me check. Index. Index. We can use the index to define that index. To the index and add is added to the piece head, and the string is formed. So this one can be a message. Can be a string. So this string can be a message. Okay. Okay, we load this piece notification, the post, need to import. And then what else? What else? Well, we need to, okay, here. Maybe this one, the skin, okay, remove, okay. Then we need to follow this one. To remove this, oh, we still some piece of message to be sent. The last one is index, okay. And let me say, okay. Let me see, I just make, so we can still use this scanner. Keep it there, okay. Option, is an option. And then we need to check if the option, okay. No, like nothing, just okay. Then we can stop. Just press enter. Press answer to quit. That's enough. So we do not need to ask any other question. No, any other options is necessary. So we just remove this one. Oh, sorry. Here, let me check. The publisher should be remove string. Remove string. Okay. Okay, just follow that. Follow that. Because no data is available, so we just remove the string. Then close the system after the user click enter, press enter after system, after all the stream is transmitted to the root. Okay, so this client, now this publisher is finished. It's not so difficult. Here we just you load the data from the disk. That's one difference from the other publisher, but not difficult. Here I have to repeat that the coding here has nothing to do with the distributed system programming, so it should be easy. Video publishing is done. Okay, next let me try. Which one should be implemented in the next step? Okay, client. We have a subscriber. Subscriber should be implemented. Now only subscriber. Oh, a subscriber, not only possible. We has after subscriber is implemented, we still have one client. Client also need to be implemented. Streaming. Okay, subscriber. We need to implement subscriber. So start this call. subscriber. Okay. Now we need to start subscriber. Okay, just follow this framework. Subscriber name, since subscriber actually is a peer, so the name is required. And now we need to open this one. We have C SaaS infrastructure or SaaS code design pattern for many times, right? Subscriber. Let me see whether we can reuse it. If so, we do not need to re-implement the code. Maybe the data may be different. Let me check. Because we have different data sources. Yes. Okay. So I have to re-implement such a code because the data is different in this case. We have different string. Okay. Subscriber dispatcher. Data is different. Okay, now this one should be able to reuse search request. This search request is sent from the client, and I think this one must be able to reused. Okay, first we need to implement this one. Now we have 4 or 5 data sources. In this case, in the framework, only one data source are available. So we need to create more code. Okay, let's close the code. Open this one. Okay, this one. All the data should be the difference. The difference from to process the incoming notification or data from the approach that process on the children. That the difference is that we have to keep data. However, when the children in the multicasting framework receive the data just to perform multicasting or broadcasting to subscriber. However, because the upper level application should be performed between subscriber and the client, so subscriber need to keep all the data. Okay. So the first data is journalist, right? Journalist post notifications right. Okay, maybe we open this one. Open the child. Because it saves us some time to type the code. Okay, now we need to create such a thread on subscriber. Okay. The code structure is the same, but the approach to process them is different. So in next classes, I will talk about how to avoid programming so much redundant code. You can see we program a lot of redundant code when we program with distributed primitives directly, right? This is all the code are originated from distributed primitives. Okay. But some of the code, most of the code are, but here the difference is that this is the approach to process incoming data on children within the multicasting framework. However, for this case, we need to change it because it's a subscriber, not subscriber. This is not children. Okay, first we need to perform broadcasting continually through invoke the child multicaster, and then let me see whether this DB can be reused. Okay, I hope it's better for us to reuse this DB. Okay, for that we have to generate the jar file again. Okay, generate jar file again. Java archive. Okay. Then the code is here. Okay, this is a new generator code. You can see this is the exact time. Okay, next we need to remove the old one. This is the old one. Remove this one. And copy the new one here. Replace it. Okay, so we can reuse this code. Just keep the data. Okay, this one is news. Let me say message. Okay, message. Then news. Okay, this is a journalist notification. So this news is kept in the database. Let me check the database again. Oh, I'm sorry. It's a banner word. Let me check here. Okay. Copy this code here. After the data is saved in the database, we need to remove it. Let me think whether there are problem or not here. Okay, this one is it should be fine. Okay, we can keep working. Maybe the database. Let me think. Okay, let's continue to work on that. Review this one. The thread different, but the code is exactly the same. Although thread is different, but the code, the name of the code, the thread is exactly the same. But they are from the different package, so we can reuse this code. Just remove the import. Remove the import arrow. Okay, we design another one. Okay, here. Okay, let us change here. Forward and keep the data. Okay, post. Message. Okay, so it's easy. Okay, then create the creator. Create the creator. They are exactly the same, but a different package, but the name is exactly the same. Okay, just remove the import. Okay, next. This one. When you program with script free, you are working within an environment that is highly patterned. That's why you can see we repeat a lot of similar tasks. That's the way we can read the performance of software development. Okay. I'll copy all the code here to save time. And then change all the code here to process the data. Okay, this macro block. This is macro block. Okay. Then what else? News feed. News feed. Okay. We do the same thing as we have done before. News feed. Okay, finished. Next, newsfeed creator. Okay. Then the last one is a little bit difficult. This is a video piece, right? Because we need to keep persist the data on the disk. That's a little bit different, but the code structure is still the same. Okay, let us copy all the data here. And then what else? First, we still need to continue perform multicast. And then we need to keep the data on the disk. Okay, keep the data on the disk. So we need to follow this code. I cannot remember exact code to save the data. Okay, so you can see here, say, file manager, right? File manager. It should be news config, right? And then the Baz is in a notification, right? The true means the data is appended. You can see, take a look at this method, right? Is appended or not? We just appended the data at the end of the video file. Okay, so it's easy. We do not need to keep the data in a stream. Maybe we can still do that, because maybe some metadata for the stream can be kept into the database. Okay. Next, the creator. This code is exactly the same, except the import information. Okay, so now all the thread for the dispatcher are finished. So we can now work on the dispatcher. This we have done for the, we have programmed such code many times, so it should be easy for us to do that. Let me check this framework again. The subscriber dispatcher, right? We just follow that. Okay, so here, okay, copy copy all this code. We just program those codes. Okay, next. This one. Let me try whether this one can be reused or not. Maybe this one can be reused, right? All right, let me try. One issue here, I just think about the problem. One potential problem for this system, maybe the database is a little bit it's possible when the data sources, the number of data sources is large, it's possible for such a system, for one child have multiple sources, right? So maybe the database should be redesigned. I just what I had done before, I just want to reuse this such database, but after just now I think about this problem. Maybe that is not proper design. It's not proper design. For this case, the database maybe one child. If we use this database, that means okay, B2 that means that only one child have the one child, a unique child, keep the one data source. But it's possible for one complete cases, it's possible for that one child have multiple data sources. Okay, right? But I think if the number of child is large, then the possibility is that one child have multiple data sources is small. So I think it's better for us to redesign this base. But we have limited time for that to think, because this one is upper level application design. This one had nothing to do with distributed system programming. So this is one issue, but I don't want to change this code here to save time. So this is one potential problem. Okay, so but I don't want to spend much time on that. But if you want to design a practical system, you need to pay much attention to that. This is just a this database is very simple, right? This is not actual database, so just a simulation. Because it's upper level application level code. So I don't want to spend much time on that. Just leave it here. Okay, and next we need to design this one, right? Let me try whether this code can be redesigned or not, can be shared or not. Yes, I think I can. We can reuse this code. Okay, just change the visibility of the code so we can reuse it. I don't want to spend program the code again. Okay, generate a binary code, and then to remove the old version. Remove this old one. And then we get latest one here, right? This is the latest one. Overwrite the old one. Import it again. And then we can reuse this search code. We do not need to program this code anymore. Okay. So here, okay, we almost finished that. But another problem is that how to search a video. That's one different issue. Search the video. Let me think. Maybe for this case we have two. Design another message if the user want to access the video. Okay, video search request. So we design another message. This message is sent from the client to the peer. The peer is subscriber. So this one is a typical message. The parent class for this one is server message, because it's sent from the client to a peer. The peer is actually in this case waiting to receive the message. So this case is a typical client server approach. So it's easy, right? You can see that that is same as this message, right? Okay, so for this case we just add a new message. Add a new message here. Radio search request. And then we need to design the response. We have programmed such code for many times. Okay, how to do that? We just follow. Okay, this is the query. New state type. Radio. Okay, what about the response? What about the response? Response is such search it should be different from the message-based search because we need to search video. So okay, so let me check. This one should be bad. Use date tab. Okay. Oh, bad. Video piece. Right? It's better you use this name. Video piece. No, bats. Radio piece. VP. Okay. So because we work on the just it's the exact same as the client server based request response. So this stream is all message stream is necessary, is required for us. Stream. Stream. Okay. So here now we need to design the thread. How to retrieve. How to retrieve the. Okay, I think maybe it's here because there's a video. The video have a message, but that message I'm not sure whether you must remember the message of the video is just 1 2 3 4. It does not make any sense. So here for this video I do not want to keep this one, just keep the publisher, right? Maybe the different publisher, so the user need to retrieve the publisher name. No. Maybe here publisher message, maybe this one we can change here. The video let me check the publisher video. We just program the publisher, right? Publisher, not about the video publisher. So now the piece, but it does not make sense. So for the user to retrieve the index, right? You can see this is the okay, let me. So the message can be category the video publisher. category video. Publish options. Okay, then we can just want to make things easy. So here just keep the publisher, because we not only have one publisher, right? For video, only one video publisher. So just search video. If the keyword is video, if the user want the query, the query from user is video, then the data is the stream is downloaded from the subscriber to the user. So just make them the code simple. I want to make the application level code as simple as possible, right? Because we have not so much time. Okay, so here meta design this code. Search video. Search. Oh, search. I'm sorry. The name is the video search. Sorry. Video search. Video search. Okay. So okay, just copy this code. Search response. Okay, so here this response, let me check problem. So we need to check whether because here we want to check whether this video is available or not, right? So here the list is the return. So here we just have to spend some more effort without then search is performed here. Okay, then maybe we do not need to use it. We can check. If this size that is larger than 0, that means the video exists. Then we can load the data from the disk. Video from the disk. Okay, how to handle that? Let me think how to handle the video. Okay, let me think. Maybe, okay. Think my concern here is when the user need to access the video, because usually the file is large, it's not proper for us to download all the files from for one time. So it's not proper for us to load all the video file into the memory and then transmit to the client. So we just need to transmit the data piece by piece. So in this case, I think we have to change here. We just not keep the publisher. Just keep the message, right? The message is the index. There is the index. We can see the publisher, right? The publisher video here. This is the index. So user just search the piece ahead. Actually, in practice, the client have two. If the file size is large, the one approach to access a large file, the user need to the client side. Maybe this request is not sent from the user actually. The data is sent from the using a code. This code run by the machine. This code sends such requests piece by piece. So until all the file is accessed. So in this case, we just want to simplify the coding. So here, when user access this, send such a query, piece ahead, and then input one index. And then this piece is downloaded from the subscriber to the client. So in practical system, such a request is sent by a machine rather than the user manually. So multiple requests are sent from the client to the subscriber. So I just want to simplify this design. So here, if this result exists, that means the piece exists, then we can use the file manager to load the data. From the disk. Let me think how to do that. Okay. File manager. Load. We use this API to load the data. The file video config. Okay, no. here. The video news config. Okay, this is the destination, right? We just use this file, news config. Okay, destination. So we can let me see where the data is persistent. Okay, data is persistent on the data path. This is the data path to save the data. DES stands for destination. So file is saved here. So we need to load the data from this file, from this path. And what about this? Because it's an index. So the index, that means we can start index. The sign, we have the sign, right? So this one we can index. The index should start from 0, right? I remember, I'm not sure. Index from the index from 0. So we can use the index multiple news config p size, right? The index is can be obtained from the message, right? Query. Oh, sorry. Maybe we can change this one. Query and the index. So the index should be input by the user. Actually, in practical system, the index should be generated by the machine. But in our case, because we have not enough time, so I just want to simplify the implementation. So here, index, right? And then this is the start index. We need to have it end index. Just +1. Okay. +1, I'm sorry. Then the data is loaded from disk. If the video is not exist, we just return no. Okay. Okay, I'm sorry. Just return no. Okay, then we can return this response to users. Okay, we spent this lecture lasted longer than before, so we haven't finished this project. I think we can continue to do that in next lecture. And until now, you can see if a framework is available, we just follow this framework. Then it's easy for us to program a application if the application have the same framework as we have done before. So because the framework is it can be regarded as a complicated code level design pattern in Grid Free. So if such a framework is available, it's easy for you to program such an application based on that. Okay, that's all for today. If you have any questions, just let me know. See you next time.